In the first example, they take the information from this introduction on page 235, and where they have 3 different kinds of pizzas that can be made by 2 different stores or pizza restaurants, pizzerias. So the prices at the 2 different places are different. And the question is, in the long run, who's going to get a better, or what's going to be a better deal for the types of pizzas and the number of pizzas that they need to purchase. So, you can do all this by hand, one by one. But what they're showing us here is that we can set all this up in matrices, and we can use matrices to determine the price of different types of pizzas that have different costs at different stores. We can eventually put the whole thing together in just a couple of matrices and give us all of our answers. So we're going to do it piece by piece, no pun intended. But the first example starts out with asking us to write a single expression giving the total price for pizzas at Lorenzo's for the Forensic Club and evaluate it. So the Forensic Club wants to, if you look above that, the Forensic Club wants to buy, what is it, 4 cheese, 3 mushroom, and 2 garbage, which must mean that there's everything on it. And then in that matrix up above where it says pizzas per club, J is what club? V is volleyball. Jazz band? Is that right? Yeah. Okay. So F is forensics. And if you look at Lorenzo's matrix, cheese is 12, mushrooms 15, and garbage is 20. So what we want to do is we want to just take pieces of those matrices and explore how we come up with the total price. And here's how this goes. So they have cheese, mushroom, and garbage. And what they did is they arranged these into a 1x3 matrix. And then they say, well, for the Forensics Club, they want 4 cheese, they want 3 mushrooms, and they want 2 of the garbage pizzas. So they've given us the matrices, and they've given us the abbreviations for what everything stands for. Now, let's just think intuitively. If they want 4 cheese and they want 3 mushroom and 2 garbage, and these are the number of dollars that each of those cost, how much are their cheese pizzas going to cost? $48. $48, 4 times 12. And their mushroom pizzas are going to be 45, which is going to be 3 times 15. And then the garbage pizzas are going to cost 40. And then their total price is going to be just adding all of those up, right? Okay, so here's how we do matrix multiplication. We take the matrix that we have here and we turn it 90 degrees. And we kind of overlap it in a way. So you take these 3 numbers and you multiply them by these 3 numbers. We took the 12 times the 4, and then we took the 15 times the 3, and the 20 times the 2. And then we added all of their values. So to write the matrix as multiplication, you don't need to have the cheese, mushroom, garbage, or the forensics name up here or anything like that. You can just put the numbers in front of you, knowing what they represent. And I'm going to write this all out kind of long. This is going to be like 12 times 4. It's up to you whether you write this down in as much detail as I am. This right here is 48, 45, and 40. So, you probably can just go straight to these 3 numbers here, but I'm showing you where they came from in terms of the notes. The idea is you're just going to be multiplying these things in your head or using the calculator to find them. So then once we have this, then what we're going to do is we're going to add all three of those numbers together. So what's going to happen is this matrix is just going to be condensed down to a 1 by 1. So it will become 48. Well, let's just do it in our head. What's 48, 45, and 40?
143 or 30.
133. So here we are. This is the total. 133. So we started with a 1 by 3 and a 3 by 1. So we took a 1 by 3 and we multiplied it by a 3 by 1. And what did we get? A 1 by 1. That looks like the absolute value of x. We get a 1 by 1. So if you look at this, the number of rows in your first matrix and the number of columns in your second matrix, that gives you the dimensions of your product. Every single time, you'll see that pattern coming up. So they give an algorithm on page 236. And, you know, it says that you take the element of the first row in the first column and you multiply it by the element of the first row in the first column. And you know, they put it into a lot of words. I guess you're welcome to read that if that works better for you. But I like to think of it like this, that you just take this first matrix, you turn it clockwise 90 degrees, and you're overlapping the numbers that you're multiplying together. I try to put a visual on this, because as the matrices become more complex, you know, thinking, well, this row and that column times that column and this row and on, it's just like this big mind game. And it doesn't work as well for me. So I try to think of this more mechanical. Let's do another one. Let's see how this comes out. So that's what we had for the first. The second example gives us matrix A, which is 1, 3, negative 2, 4. And they want us to multiply that by B. Which is 0, 5, 2, 3, negative 1, and 4. We want to do this by hand. So in this case here, we can't just take these 4 and put them on top of those 4. That's not really what we need to do with this. We need to take and multiply this row here times each of the columns. So we need to take row 1, multiply it by each of the 3 columns, and then come back and take row 2 and multiply it by each of the columns. So this, you know, we're going to teach you how to do these by hand, but then we're going to let you do a lot of them in the calculator once you can. In terms of what I expect you to be able to do on quizzes and tests, I expect you to be able to do them by hand. But I'm also going to expect that many of these problems you're just going to do them in the calculator once you can get this done. Because you can see just from a 2 by 2 and a 2 by 3, there's going to be a lot of work here. Multiply each and every one of these combinations of elements. So let's do this. Let's start with row 1 times column 1, column 2, and column 3. So we've got 1 times 0. And then we have 3 by 3. So we're going to add that. That's going to become one term as we move forward. 1 times 0 and 3 times 3. And then we'll take row 1 and we're going to move over column 2. So it's going to be 1 times 5 and 3 times negative 1. So that's going to be your second term as you go across. And then 1 times 1 and 3 times the 2 and the 4. So these are going to be the 3 terms that are in that first row of your product. And then we do the same thing with negative 2 and 4. We take that times the 0 and the 4, we write that, the sum of those two products under here, and keep working our way across the matrix B. So we take these two times 0 and 3. And then those get worked all the way across the matrix. So in the book, they show us then performing all of the multiplication and addition and coming up with each of the terms in your final matrix. On paper, if you wish to just write your sums of these products underneath here, and then put a line through that work, you're welcome to do that as well, however you wish to organize it. But this first one here would be 1 plus 3 times 3, which is going to be, oh no, sorry, 1 times 0 is 0, isn't it? So you just have 3 times 3, which is 9. 1 times 5 plus 3 times negative 1 is 2. 1 times 2 plus 3 times 4 is, yeah. And this one's going to become,
10.
how much?
10. Oh, well, 6.
6. And this is going to become
Negative 14.
negative 14, and that's going to become,
Wait, would it be negative 2 times 0? Or the bottom one?
oh, sure enough, I screwed up. Good job. 0, 0, 3, 3, 5, 5, negative 1. Good, thank you. What do we have then? It's going to be, that's going to be 10.
12.
12. Yeah. So you guys are going to be just fine with this stuff. Is this negative 14?
Yeah.
And then that's going to be 12. Yeah, that's what I have. I don't know if that's right. Okay, so let's go back here. This is a 2 by 2, yes? Multiplied by a, what's this one? 2 by 3. So what do we expect the product to be?
2 by 3.
A 2 by 3, yeah. These first terms, is this a 2 by 3? Yeah. So that's going to make sense.
Oh, so that's kind of like a way to check if you did it right.
Yeah, and it's a way to lay out, what do I expect? You know, so if you take a 3 by 4 and a 4 by 3, you're going to expect to get a 3 by 3 when you're done. So you'll know that you're laying out all of your multiplication and your addition properly as you work.
So that's true for all multiplication?
All.
Okay.
Yeah, that's the definition of matrix multiplication. If A is an m by n and B is an n by q, then the matrix product of A and B is a m by q, whose element in row R and column C is the product of row R of A and column C of B.
Okay.
Got that? Willa just shook her head. It's like crossing a river. Get to the other side, shake it off. Yeah, so it's, if you have an M by an N, and that product is with an N by a Q, you're gonna get an M by a Q, always. And then there's one last one here. It says we can use a cast to do this one, or your graphing calculator. I mean, you can do it. I'm gonna set them up though, up here, just because I think it's some good practice to be able to lay them out and see where our products come from. So they've got three matrices, M1, M2, and M3. And we're supposed to look at the product of these three. And what we're doing is we're looking at the associative property. We're asking ourselves, does the associative property work with matrices? Big question. So, M1 is this matrix. I've got M2. And M3.
Wait,
Yeah?
so we can know if we can multiply something or not multiply something by if the second one and the first one aren't equal?
Yeah, exactly. Let's say I took a 1 by 3 and I multiplied it by a 2 by 4.
We can't do that then.
You cannot, you're right. Why?
Because the column and the rows, if you were to turn the one, it's not gonna work,
Yeah,
right?
that doesn't work. But you could do a 1 by 3 with a 3 by 4. So there's a 1 by 2. Okay? This is a 2 by 3. Yes? So you see the 2 and the 2?
Yeah.
It works.
Okay.
Then this is a 3 by 1. So can we multiply these two together?
Yeah.
Yeah. So now what we can do is we can explore. Let's say we take the first two and multiply them together, and take that product times the last one. So here's a bunch of good eye, good way to think about it. You're looking ahead. If we did a 1 by 2 times a 2 by 3. What's the product going to be?
1 by 3.
A 1 by 3, yeah. And then can I take the product of those two, and can I take that and multiply it by 3 by 1?
Yeah.
What are you going to get?
1 by 1.
A 1 by 1. Okay, so now let's back up. Can I do a 2 by 3 times a 3 by 2?
Yeah.
And that's going to give you
2 by 2.
a 2 by 2. So if I did those first, and then I came back and I took the first one, which is a 1 by 2 times that,
Yeah.
that works, the 2's, and it's going to become a 1 by
1
2.
by 2.
a 1 by 2. So just look at this. If we do these two first, and then times that, we get a 1 by 1. If we do these two first and take it times that, it looks like we're going to get a 1 by 2 if I'm doing everything right here. And that's going to be a different matrix, isn't it?
Yeah.
So it doesn't look like they're associative. Let's find out.
Wait,
Wait.
so you can only multiply them if the first one's column is equal to the second one's rows?
Yep. First one's columns have to be equal to the second matrix's matrix row. Okay, so let's go up on top here and let's do M1 times M2. And then take that product and take it times M3. Now you can put these into the calculator and you can do them that way as well. Gosh, I want to show you both. But I want to, let's do one at least by hand here. Okay, so we gotta take 4 times -2 and 3 times 3. You good? 4 times 4 and 3 times 6. And then 4 times 1 and 3 times -5. So let's just write their products and sums right here. What's the first element going to become?
$34.
16 plus
18.
18. And the last element becomes -11. Okay. So that's M1 times M2. And now we have to take that product right here times M3. So this is M1 times M2. Now we're going to take it times M3. And that's going to be equal to what we have right here. So now we take 1 times 6, 34 times 11. What's 34 times 11? 340 and 34. 374. And -11 times 2 is -22, and we have to add these. Because we're going to get ourselves a 1 by 1, right? So now, let's come back and do M2 times M3, find that product, and then multiply it by M1. So I'm going to put M1 in front here. And then we're going to take these two, multiply them together, and put their matrix down here. So we have to take the -2, 4, and 1, and multiply them by the 6, 11, and the 2. So -2 times 6 plus 4 times 11 plus 1 times 2. That's our first element. Oh shoot, I need one more time. Well, that's okay. Be done with it. I'll take a picture of this, and we'll pick up on it on Monday. I mean, if you're like bored stiff later today and you feel like working into the homework, have at it. But the bottom line is this. We'll finish talking about it on Monday and give you time to work on Monday, and it's not going to be due until Tuesday. Okay? So it's up to you if you want to dig into it or not. 40 minutes went a little fast.